Hello dear students, I am Ronak Kumar, your physics faculty at Aakash, and I welcome you all in this session in which we are going to discuss the problems of mock test 5 that was conducted under AIATS plus phase 2, and this paper was conducted on 16th of February 2025. Now I will be taking the problems based on the chapters of current electricity, motion in a straight line, kinetic theory, thermodynamics, alternating current, and electromagnetic waves, right? Important chapter from the point of view of NEET examinations, right? You can expect a lot of problems from these chapters. Now let's move forward to the first problem, and the first problem, it is problem 2 of the original paper. It says that a steady current flows in a metallic conductor of non-uniform cross section. So a steady current is flowing, and it is flowing in a non-uniform cross section. So the keyword over here is non-uniform, right? So a current is flowing through a non-uniform cross section. The quantity or the quantities remaining constant along the length of the conductor. So you need to pick the quantities that remain constant along the length of the conductor. Okay. So just to give you a reference, a conductor with a non-uniform cross section can look like this, right? Let me erase it. Let me make it again. So I have a conductor which is having a non-uniform cross section, something like this, right? Now let's discuss. So we need to comment about the current. We need to comment about the current, the electric field, the drift speed, right? And you need to pick which one will remain constant throughout the length of the conductor. Now dear students, suppose that current I goes in here, and if there is a steady flow, then current I will come out over here. If this much current goes inside, then this much current has to come out, which means that the current, I'm talking about the current is going to remain constant throughout the length of the conductor, right? Now, let me assume that area of cross section at this side is A1 and area of cross section at this side is A2. The first point of conclusion is that current is going to remain constant throughout the length of the conductor. And cross section over here, this part is A1, cross section over this part is A2. Let's talk about the current density. What is current density? See, current density J, it is defined as I over A. I'm talking only about the magnitude part. Current density, it is defined as current divided by the cross sectional area, right? Suppose that I want to define current density at this part. Right, I want to define the current density at this part. How can I write? I can write it as I by A1. And how about the next part? I can write current density over here as I by A2. Now you can see that I by A1, I have I by A1 and I have I by A2. Current is same, but the area of cross section is different, right? So I by A1 will not be equal to I by A2. I by A1 will not be equal to I by A2. And what can I conclude from this piece of information? I can conclude that the current density that we were talking about, it is not going to remain constant throughout the length of the conductor. It is going to change, and it is right in front of you that it is going to change. I by A1 will not be equal to I by A2. So current is same, but the current density is going to vary because the cross-sectional area is going to vary. So let's talk about the next part. We also need to comment about the electric field. So for the electric field, have a look at this equation. J is equal to sigma E. Now there are three terms over here. J is the current density, sigma is the conductivity, E is the electric field. Now we very well know that current density is going to vary, and we need to comment about the electric field. Now if I modify this equation, sigma can be written as equal to J by E. Now this sigma, it is a property of material, and if you are having a one conductor, if we are talking about the one conductor only, then this sigma is also going to remain constant. Now since sigma is going to remain constant, it means that if J is changing, then electric field has to change also, so that this constant ratio is maintained, right? Okay, good morning to everyone. So J by E, this ratio has to, if J is changing, then electric field also has to change to keep this ratio as constant. So yes, electric field is also going to vary. And the last part, we also need to talk about the drift speed. So drift speed, what expression do you use? So I, it is equal to NEAVD. Here I is the current, N is the number density, E is the electronic charge, A is the area of cross section, and VD is your drift speed. Now these two terms, NE, they are not going to vary for a conductor. If you are having a single conductor, then the number density or the value of E, it is not going to vary. Current is needs to remain constant throughout the length of the conductor, right? The point of consideration over here is that current is going to remain constant throughout the length of the conductor, which means that the product of area of cross section into drift velocity should also remain constant. A into VD should also remain constant. Now dear students, area of cross section is changing and the product needs to remain constant, which means that you also need to change the drift velocity, right? So, or the drift speed. So yes, drift speed is also going to change. So what is the final conclusion of all this discussion? It is that the current is going to current is not going to vary throughout the length of the conductor. Talking about the electric field, yes, it is going to vary. Talking about the current density, yes, it is going to vary. And talking about the drift speed, yes, it is also going to vary. Now let's have a look at the option. Option 1 says that current, electric field and drift speed, all the three quantities, they are going to remain constant. So this one is wrong. Drift speed is not going to remain constant, and electric field, obviously it is not going to remain constant. Let's talk about the second part, drift speed only. No. Current and drift speed, no. Current only, yes. The current is the only quantity among all these 3 or 4 which is going to remain constant. So yes, the correct answer to this is option 4, right? I hope you understood all the concepts that were involved in this problem. Now let's move forward to the next problem, and it is problem 7 from the original paper of your mock test 5. It says that the potential difference across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in a LCR circuit. So you have been given the voltage drop across the resistor, capacitor and inductor in a series LCR circuit connected to an AC source. And what they are asking from you, is the power factor of the circuit. So they want you to calculate the power factor of the circuit. Now to calculate this, what is power factor? See, power factor, if I talk about power factor is cos of phi. This cos phi term, it is known as the power factor. What is phi? Phi is the phase difference between the current and the voltage. Suppose that if I try to draw the impedance triangle, let me draw, see, I have a series LCR circuit like this. This is my inductor, this is my capacitor. Sorry, this is my resistor and this is my capacitor. They are connected to an AC source, something like this, right? So this is R, not R, sorry. This is your L, this is your R, and this is your C, right? Now, if I try to draw the triangle, VR voltage across the resistor will be in this direction, and obviously current is also going to be in this direction only, the current that is flowing through this. I'll draw in the next page. So VR is over here, current is also over here. They are in the same phase. Voltage across the inductor, it leads current by a phase difference of pi by 2, and the voltage across the capacitor, it lags the current by a phase difference of pi by 2, right? Suppose that I'm assuming VL is greater than VC, then the resultant of this part will be over here, VL minus VC, and which means that the net voltage will be along this direction, current is along this direction, this phase angle is phi, and cos of this phi is known as the power factor, right? So cos of this angle phi is known as the power factor. You can also see that the value of cos phi, it is equal to R by Z. You can get it from the impedance triangle. Here is your R, here is your XL minus XC, and this would be under the root of R square plus XL minus XC whole square. So this angle cos phi, it will be equal to R by Z, or it can also be written as VR by V. This is your V, right? So I hope I made it clear what is power factor, how to the concepts involved while dealing with the problems of power factor. Now let's move to the problem. So it says that you have voltage across the resistance as 80 volts. So this VR, it is 80 volt. What else? You have across inductor you have 40 volt. So this is 40 volt. And across the capacitor, sorry, not, okay, just. So you have across the resistance as 80 volt, across the capacitance as 40 volt. So this is 40 volt. And across the inductor you have 100 volt. So this is 100 volt. Right? This is the phasor diagram. Now, the net resultant of this 100 and 40, it will be 60. So 60 is somewhat here. This is 60 volt. And the net voltage will be along this direction. It will be equal to under the root of 60 square plus 80 square, which is eventually coming out to be equal to 100 volt. So this is your current. This is your net voltage. So this angle becomes phi. And the value of cos phi from here, it is equal to VR by V. What is VR? It is 80. Net voltage, it is 100. So 80 by 100, it becomes 0.8. That's how you solve the problems of power factor. I hope this problem is clear to you, right? So correct answer to this problem, it is option 3, 0.8, right? Now let's move forward. And if you understood the concept, have a look at this problem. It is an actual problem asked from the NEET 2020. And it says that a series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between current and voltage is pi by 3. So L is removed, the phase difference is pi by 3. If instead C is removed, the phase difference is again pi by 3 between current and voltage, the power factor of the circuit is. So you have been given two conditions. And in the first condition, L is removed, the phase difference is pi by 3. In the second condition, the capacitor is removed, again the phase difference is pi by 3. So you need to basically comment about the power factor of the circuit. And it is an actual problem from the NEET examination. Any one of you, if you know the answer, you can put the answer in the comment box. And it is a fairly simple problem, just a little bit of tweak to the previous problem. And if you understood the concept, if you're thorough with the concept, you can solve this problem in a jiff. So if I see, let me draw the impedance triangle. So this is your R, right? This is your XL and this is your XC. Now the problem says that when L is removed, so when L is removed, so let me remove L. So I have removed L, the phase difference is pi by 3. So Z comes over here and this phi. So I can write that cos phi, it is equal to R over Z, and Z will be equal to under the root of R square plus XC whole square, and cos phi is pi by 3, cos 60 becomes 1 by 2. So this is 1 by 2. This is the first part of the problem. Now they say that first they removed L, now they are removing the C. So they are removing the C. Let me remove C. So this is your R and I have removed C. So there goes my XL. So this time the impedance comes like this, Z, which is equal to under the root of R square plus XL square, and this becomes phi. So cos phi, again it is 1 by 2, it is equal to R over under the root of R square plus XL square, and for the previous case again cos phi was equal to 1 over 2, it is equal to R upon under the root of R square plus XC square. Right? Okay, and no one is getting the answer to this problem. Okay, this is my equation 1, this is my equation 2. If I compare the equation 1 and 2, they are equal. It means that R upon under the root of R square plus XL square, it should be equal to R upon under the root of r square plus xc square. What I mean to say is that r upon under the root of r square plus xc square, it should be equal to r upon under the root of r square plus xl square, right? So from this part I can write that xc should be equal to xl, because that is the only condition in which both of these, the equations or the terms written on the left hand side and on the right hand side, they will be equal only if xl is equal to xc. And dear students, it is a very famous concept from the chapter of alternating currents that if xl is equal to xc, it means that it is a condition of resonance. And what is the power factor at resonance? It is a standard result. What should be the power factor at the resonance? Anyone can give me the answer in the comment box. What should be the power factor at resonance? So you can see that for resonance, okay, so for resonance part, if I try to draw the resonance, so this is R and this is XL and this is XC. So both of these, they will cancel each other because XL is equal to XC. So cos phi, which is equal to R by Z, for the condition of resonance, Z is equal to R. So cos phi, it becomes R by R, and that comes out to be equal to 1. So the value of cos phi is coming out to be equal to 1 for the condition of resonance. So yes, this problem, you need to understand that this problem was given for the condition of resonance, and the correct answer to this problem is option 4, right? Yes, someone got the answer D. Yes, D is the correct answer. It was the condition of resonance. So you must remember that for the condition of resonance, the power factor is going to be equal to 1 because the XL part is equal to the XC part. So Z, it becomes equal to R only. It means that there is no phase difference between the voltage as well as the current, right? Yes, XL equal to XC. Now let's move forward to the next problem. And yes, the next problem again from the chapter of alternating current. Sir, please tell me where I can get PDF of this. Okay, I'll talk. How can you get the PDF of this part? Let's head back to the problem. It says that problem 9. It says that equation of alternating current is given by I, that is equal to 20 root 2 sine 200 pi t. The RMS value of current is what you are required to find. So RMS value of current. Dear students, what is the funda behind introducing the RMS value? RMS value, you can understand it as that RMS value, you can understand it to be DC equivalent while dealing with the alternating current. So you need a DC equivalent to compare the results between the DC current and the alternating current. So RMS, you can treat it as DC equivalent. So you have been given an equation. That is I, and this is equal to 20 root 2 sine 200 pi t. This is the equation that is given to you, and you have been asked the RMS value of the current. So RMS, IRMS or any RMS value, it is equal to the peak value divided by the root 2. IRMS is equal to I naught by root 2. I naught is the peak value. So peak value over here is that it is 20 root 2. So 20 root 2 by root 2, which gives you answer as 20. So 20 ampere is the RMS value of the current, which is having the peak value as 20 root 2. Yes, equal amount of heat generated by DC current. Yes. So 20 ampere is the answer to this problem, right? Which means that correct answer is option 3. So I hope I made this point clear, and if you understood what is the concept behind the RMS current, have a look at this problem. This was the problem that was asked in NEET 2022, and a very recent paper, and it says that the peak voltage of the AC source is equal to peak voltage V naught. V naught is the peak voltage, and you need to relate it with the RMS value. So if V naught is the peak value, VRMS is the RMS value. So you need to comment what should be the relation between V naught and VRMS. So dear students, it's a very simple problem. VRMS is defined as peak value divided by the root 2. Vrms is V naught by root 2. So if you need to comment on the peak value, है ना? If you need to comment about the peak value V naught, it should be equal to root 2 times the Vrms. So V naught is root 2 times the Vrms. It means that the peak value, it is root 2 times of the RMS value. It is root 2 times the RMS value. So correct answer should be option 2. Root 2 times the RMS value of the AC source. So this one is wrong. 1 by root 2 times is wrong, and the value of voltage supplied to the circuit is also wrong. Yes, second option is the correct answer. It is a fairly simple problem, and it was also asked in the actual NEET examination. So you get such kind of problems in the paper, which are easy, but you seem to miss them under the pressurized environment of the paper. So always approach the paper with a calm mind. Now we are thorough with the concept of RMS and the peak value. So let's move forward to the next problem. There you go, and this problem is from the chapter of electromagnetic waves. This problem is from the chapter of electromagnetic waves. It says that, and it was problem 11 of the original paper, and it says that in an apparatus the electric field was formed to oscillate with an amplitude of 18 volt per meter. The amplitude of oscillating magnetic field will be. So you have been given the the peak value of the oscillating electric field, and this time they are asking you to calculate the peak value of the oscillating magnetic field. And if nothing is given, we are assuming that this electromagnetic wave is going in the free space. So from the properties of electromagnetic wave, I can write that if the wave is going in a free space, C, it should be equal to E naught by B naught. What is E naught and what is B naught and what is C? C is your speed of light, okay, and EM wave, it is going in a free space with the speed of light. E naught is the peak value of oscillating electric field, and what about B naught? Going with a similar logic, what is B naught? B naught is peak value of oscillating magnetic field. So you need to use this concept to solve this problem. So C is equal to E naught by B naught. So the value of C is 3 into 10 raised to the power 8. It should be equal to E naught. What is the value of E naught? The amplitude of oscillating electric field, it is 18, and B naught is what I am required to calculate. So B naught will be equal to 18 by 3 into 10 raised to the power 8, which means that it is coming out to be equal to 6 into 10 raised to the power minus 8, and the units will be Tesla. Yes, 6 into 10 raised to the power minus 8. So yes, correct answer is option, 6 into 10 raised to the power minus 8 Tesla, and it is given to me in option 3. Now, if you understood this concept, have a look at this problem. There you go. This is the problem right in front of you. If you got the previous problem, you can attempt this problem and give me the answer to this problem. And there are no options. You just need to calculate it, and you need to put the answer in the comment box, right? And I'll go through the problem for you. It says that the magnetic field in a plane electromagnetic wave is given by By, that is equal to 8 into 10 raised to the power minus 6 sine 5 into 10 raised to the power 3x plus 3 into 10 raised to the power 11 t. The amplitude of oscillating electric field will be. So this time you need to calculate the amplitude of the oscillating electric field. Let me write the equation for you. The equation for the magnetic field associated with the electromagnetic wave, it is given to me as 8 into 10 raised to the power minus 6 sine 5 into 10 raised to the power 3x plus 3 into 10 raised to the power 11 t, right? So the standard equation By, it can be written as B naught sine omega x plus kt. So from this Okay, 2400. Someone is, no, 2400 is not the right answer. Check the calculation, check the concept, and I can tell you that 2400 is way forward than the actual answer. The actual answer is somewhat 480. Actual answer will come out to be equal to 480. And just see where did you go wrong. So B naught, the amplitude of oscillating magnetic field, this time it is given to me as 8 into 10 raised to the power minus 6. Now, going with the similar logic that we just discussed in the previous problem, I am bound to write C to be equal to E naught by B naught. Many of you must be using this formula, C that is equal to E naught by B naught, but this formula this time over here is wrong. You cannot use this formula C to be equal to E naught by B naught because electromagnetic wave, it is not going in a free space. This time, you need to calculate the velocity of the wave, which will be velocity of the wave, it will be equal to E naught by B naught, and this time velocity of wave will be calculated by omega by K. Since they have not mentioned that it is going in a free space, you need to calculate the velocity of EM wave, and it will be equal to E naught by B naught. So omega, you can see that it is 3 into 10 raised to the power 11, and K is 5 into 10 raised to the power 3. So 5 into 10 raised to the power 3. So if I write 3 into 10 raised to the power 11 over 5 into 10 raised to the power 3, it should be equal to E naught by B naught. What is the value of B naught given to me in the problem? The value of B naught is 8 into 10 raised to the power minus 6. So there you go, 8 into 10 raised to the power minus 6. So let me calculate the value of E naught for you. So E naught is 3 into 10 raised to the power 11 into 8 into 10 raised to the power minus 6 upon 5 into 10 raised to the power 3. So it becomes 24 by 5 and 11 and minus 9, it becomes 100. So 520, so it is coming out to be equal to 480 volt per meter. It is coming out to be equal to 480 volt per meter, not 2400 volt per meter. And I can see that how can you get the answer 2400? You can get it by 2400 if you are getting, it should be equal to 3 into 10 raised to the power 8, and you multiply it by the 8 into 10 raised to the power minus 6. There you go. That's how you got the answer 2400. But this is completely wrong. This is completely wrong. You cannot solve this problem with the approach that we just discussed. So you need to be thorough, you need to be using your mind, your presence of mind while dealing with the problem. Every problem is not the same, and that's why we have this AIATS Plus, the personalized learning. It helps you to tackle the problems of the same concept again and again. Okay, the concepts, and if the problem is of different variety, you also get the taste of different varieties also. So I hope I made this part clear, that how to deal with such kind of problems. Now let's move forward, and there you go. This is the problem 18 from the original paper based on the chapter of motion in straight line. It says that position of a particle moving along x-axis is given by x equal to 4t plus 5t square. X is in meter, t is in second. Acceleration of a particle at t equal to 2 seconds will be. So this time you need to find the acceleration of the particle, and you have been given the equation of position of the particle as a function of time. So differentiating it once, that is dx by dt, will give me the velocity, and differentiating it once more, that is dv by dt, will give me the value of acceleration, or I'll get the equation of acceleration as a function of time. I'll put t equal to 2 seconds and I'll get my answer. So equation given to me is x, that is given to me as 4t plus 5t square. Okay, if I differentiate this, someone is giving the answer, v, it is equal to dx by dt, and if I differentiate it, it will become 4 plus 10t. So v is coming out to be equal to 4 plus 10t. Now what do I need to get? I need to get acceleration, so I'll differentiate it once more. A, that is equal to dv by dt, it is equal to 10. So acceleration is constant. Whatever is the time, the value of acceleration is going to remain 10, and 10, the units is 10 meter per second square. So this time you have a constant acceleration. So if they would have asked the acceleration at t equal to 4, t equal to 6, t equal to 8, the value will still remain the same. That is 10 meter per second square, right? Yes, d2x by dt square. So correct answer should be option 4. So can anyone tell me what should be the value of velocity at t equal to 2 seconds? Someone can give me the answer that what should be the velocity at t equal to 2 seconds? It's a simple problem. Just put t equal to 2 over here. So it becomes 4 plus 10 into 2, 20, 20 plus 4, 24 meter per second. You can also get the position at t equal to 2 seconds. A simple problem. You just need to be thorough with the concepts of differentiation. Not much of a physics involved over here. So correct answer is option 4. Yes, 24. Now let's move forward to the next problem. Yes, and this problem again from the chapter of motion in straight line. It says that problem 24 of the original paper, it says that a body is thrown vertically upward such that the distance traveled by it in 5th and 6th seconds are equal. Now this time a piece of information is given to you that if a body is thrown vertically upward, the distance traveled by the body in the 5th and the 6th second, they are equal. You need to calculate the maximum height reached by the body. So this time you are being asked to calculate the maximum height reached by the body. So, if I try to draw the trajectory of the body, it will be something like this. So the body is, suppose it is projected with the velocity of u from here. So it reaches it at the maximum height. And the distance traveled by the body in the 5th and the 6th second they are equal. So this is t equal to 4, this is t equal to 5, and this is t equal to 6. So between 4 and 5, this is your 5th second, and between t equal to 5 and t equal to 6, this is your 6th second. And that's why they are saying the distance traveled in the 5th and 6th second are equal. Now you must be wondering that how am I so sure that this should be t equal to 4 and this should be t equal to 6. See, the concept or the piece of information that is given to me is that the distance traveled in the 5th and 6th second are equal. And I know that if the body reaches at the maximum height, so the distance covered in the last second of upward motion, the distance covered in the last second of upward motion should be equal to the distance covered in the first second of the downward motion. Distance covered in last second of upward motion. Upward motion, this part is the upward motion, the portion to the right. If I draw a dividing line, the portion to the left is the upward motion, and the portion to the right is your downward motion. So distance covered in the last second of upward motion, it is equal to distance covered in first second of downward motion. So this is the concept that we are going to utilize. The distance covered in the last second of upward motion, it is going to be equal to the distance covered in the last second of downward motion. That's the concept I utilize to figure out that this should be t equal to 4, this should be t equal to 5, this should be equal to t is equal to 6. Now I need to figure out what should be the maximum height. So I can see that the total time taken by the body to go from A to B, it should be equal to 6 plus 4, that is 10 seconds. So total time of flight should be equal to 10 seconds. It means that the time taken for the upward motion t half, it should be equal to 5 seconds. Now I assume that it is going with the velocity, it is projected in a vertically upward direction with the velocity u. So I can write that h max, it should be equal to u square by 2g. H max should be equal to u square by 2g. Let me calculate u also for u. So I can use the equation v to be equal to u plus at, at maximum height, V is going to be equal to 0. So 0 should be equal to U. U is in vertically upward direction. Acceleration due to gravity is acting downward direction. So U minus GT. So U is coming out to be equal to G into T. G into T. G is 10 and time taken to reach maximum height is 5. So it is 50 meter per second. 50 meter per second. Put it over here. So 50 into 50 by 2 into 10. So 225. So it is coming out to be equal to 100 and 125 meter. 125 meter is the maximum height. Option 3. 125 meter is the maximum height, right? So dear students, 125 is the maximum height, and you also calculated what should be the velocity of projection. It should be 50 meter per second. From here, it is coming out to be equal to 50 meter per second. So yes, 50 meter per second is the velocity of projection. You also calculated the total time taken for the motion, the time taken to cover the upward part, the time taken to cover the downward part. So that's how you deal with such kind of problems. And in the comment section, they are talking about the Cobra. So let's ignore Cobra and let's focus on what should be the, what is the concept involved in the numerical. So yes, the correct answer is 100 and 125 meter. Now this is a fairly, a little bit of advanced problem as we see it. Many students are confused that what is exactly the meaning of this part, that distance covered in fifth and the sixth second are equal. And I hope I made this point clear. Now let's move forward to problem 28. Problem 28, and this problem is based on the topic of thermodynamics. It says that when an ideal gas expands adiabatically its temperature. So this time adiabatic expansion of an ideal gas is taking place. They are talking about the temperature. So what is the, I can approach this problem with two methods. Let's first go with the mathematical method. I know that the process equation for the adiabatic process is PV raised to the power gamma to be equal to constant. So if I need to comment about the temperature, so I need an equation between the volume and the temperature. So in place of P, I'll write nRT by V into V raised to the power gamma to be equal to constant. So if I solve this, it becomes T into V raised to the power gamma minus 1 to be equal to constant. Right? This is the equation between the temperature, and someone is giving the answer increases. This is the, this is the equation. And let's solve this. So T1 V1 raised to the power gamma minus 1, it is equal to T2 V2 raised to the power gamma minus 1. So from here I can write that T1 by T2, it is coming out to be equal to V2 by V1 raised to the power gamma minus 1. Now since the gas is expanding, it means that V2 is greater than V1. So V2 is greater than V1, it means that this ratio T1 by T2, this ratio T1 by T2 is also greater than 1. The ratio T1 by T2 is greater than 1. It means that T1 is greater than T2. Now T1 is the initial temperature, T2 is the final temperature once the expansion is going on. So you can see that if the adiabatic expansion of an ideal gas is taking place, mathematically we can see that the temperature of the gas is decreasing. So it is not increasing, it is decreasing. So this was the mathematical part to deal with this problem, but we can also go with the energy logic to solve this problem without even lifting up pen. See, in the process of adiabatic expansion, we all know that there is no heat interaction taking place. So from first law of thermodynamics, you can see that delta Q, it is equal to delta U plus delta W. And since we are talking about the adiabatic process, so heat interaction will be equal to 0. Delta Q will be equal to 0. Now you are left only with the internal energy and the work done. Now the gas is expanding. It means that the work is being done by the system. Delta U is 0, so why is temperature increasing? Not delta U is not 0, delta Q is 0. Delta U is 0 for the isothermal process. We are talking about the adiabatic process. So in the adiabatic process, delta Q is 0. So that means that the whatever work is being done by the system, it is being done at the cost of the internal energy. Say if the system is expanding and the system is doing work, then the energy to do that work is coming from its own internal energy. So if the system is doing the work, in that case its internal energy will decrease. And for an ideal gas, if the internal energy is decreasing, it means that the temperature is going to decrease, right? So temperature is going to decrease. Now someone is asking me, sir, what about expands isothermally? So for isothermal expansion, delta Q, the heat interaction, should be equal to the work interaction, because in that case the change in internal energy is zero. So whatever heat is being given to the system, that part is utilized for the work done by the system. So if I talk about the isothermal part, let me talk about the isothermal part. Isothermal. So for the isothermal part, you can see that delta U is 0. So delta Q, it is equal to delta W. So whatever heat you will give to the system, the system will perform work based upon this equation, delta Q is equal to delta W. But we are talking about the adiabatic expansion. So yes, the work done by the system, it is coming at the cost of its own internal energy. So that's why the temperature is going to decrease. Had it been the work done on the system, so no heat interaction is there, that part would have increased the internal energy, and it means that if the work was done on the system or the gas was going adiabatic compression, in that case the internal energy would have increased. So for the adiabatic expansion, the temperature is decreasing. For the adiabatic compression, the temperature would have increased. So correct answer to this is decreases. Option 2 is the correct answer to this problem. So I hope I made this point clear. How to deal with the concept of adiabatic expansion, adiabatic compression, isothermal expansion or isothermal compression. Now let's move forward to the next problem. And there you go, this is a problem 30 from the original paper, and it is based on the meter bridge. In a meter bridge, 2 ohm resistance is connected in the left gap, and the balancing length from the left end is found to be 20 centimeter, the value of unknown resistance. So this time you need to calculate the value of unknown resistance. Let me draw the circuit for you. So this is 2 ohm resistance connected in the left gap, and this is alpha, your unknown resistance. And let me draw this, and this is your, and the balancing length from the left end is 20 centimeter. So this is 20 centimeter. It is a meter bridge, so this part will be equal to 80 centimeter. So you need to find out the value of alpha. Can anyone give me the answer to the value of alpha? This is standard problem based on the concept of Wheatstone bridge. If you are getting the null point, then this is the condition for the balanced Wheatstone bridge, for which I can write that 2 by 20, it should be equal to alpha by 80. 2 is the known resistance in the left gap, alpha is the unknown resistance in the right gap, 20 is the balancing length from the left end. So this part becomes 100 minus 20, that is 80. So if the ratio has to be maintained, then alpha by 80 should be equal to 1 over 10, which means that the value of alpha should be equal to 8. The value of alpha should be equal to 8, or the value of unknown resistance, it should be equal to 8 ohm. And it is given to me in option 3. So 1, 2 and 4, they are wrong. Simple problem based on the concept of meter bridge. And if you are thorough with the problem, attempt this problem. There you go, the problem is right in front of your screen. It says that in a meter bridge circuit as shown in the figure, the bridge is balanced when AJ is equal to 20 centimeters. So this is the AJ, and this meter bridge is balanced when AJ is equal to 20 centimeter. On interchanging P and Q, the balance length shifts by. So this time we are exchanging the value of P and Q. So initially P was in the left gap, Q was in the right gap. I have switched the position. Now Q is in the left gap and P is in the right gap. Now you need to comment what amount the balancing length will shift. So if I try to solve this, for the first part, for the initial part, I can write that P by AJ, the value of AJ over A is 20. So P by 20, it should be equal to Q by 80, right? So from here I can write that P by Q, it is coming out to be equal to 80 by 20. So P by Q, it is 80 by 20. So P by Q, it is equal to 4 by 1. Right? Okay, someone is telling me the answer remains same. No, it doesn't remain same. The value of P, let me assume that the value of P is 4K, and let me assume that the value of Q is K. Now I am switching the position. Now Q is in the left gap, Q is in the left gap, and P is in the right gap. And let me assume that the balancing length from this end is L1. So this end will become 100 minus L1. I have, switched the resistors. Q is in the right gap. Sorry, Q is in the left gap, P is in the right gap. Balancing length I have assumed from the left end is L1. So this part becomes 100 minus L1. Now let me give the condition. So Q by L1, it should be equal to P upon 100 minus L1, which means that the value of Q is K, and this is L1. The value of P is 4K, and it is 100 minus L1. Let me cancel this K and K. So from here, 100 minus L1 is coming out to be equal to 4L1. Okay. So 5L1 is coming out to be equal to 100. So yes, L1 is coming out to be equal to 20 centimeter. Okay, so L1 is coming out to be equal to 20 centimeter. Okay, yes. So balanceless shift by. Dear students, I hope you got the concept. Now let's move to this problem. In the given figure, current in some branches of an electrical circuit is shown. The value of I is what you are required to find. You need to find the value of I. This is a problem based on the concept of, the incoming current must be equal to the outgoing current. So incoming current, it should be equal to the outgoing current. So what is the incoming current at this junction? You have 7 ampere, 2 ampere and 4 ampere. 7 plus 2, 9 plus 4, 13. So 13 ampere is the incoming current, and it should be equal to outgoing current. So, okay, one part I missed. So incoming current is 7 to, okay, no, 4 is not incoming current. Let me rub it again. Let me rub this part. Let's talk about this junction. So I'm talking about this junction. So incoming current is 7 ampere, 2 ampere and 3 ampere. So 7 plus 2, 9 plus 3, 12 ampere is the incoming current, and it should be equal to the outgoing current. That is 4 plus I plus 3. So 7 plus I. So I is coming out to be equal to 5 ampere. I is coming out to be equal to 5 ampere, right? Simple problem based on the concept of incoming current should be equal to outgoing current. And yes, P by Q is 20 by 80. Okay. We are talking about the P by Q. Okay, a little bit of calculation glitch over here. Sorry, P by Q. P by Q is 20 by 80. So yes, a little bit of calculation mistake over here. So P becomes K, Q becomes 4K, and I have to reverse this ratio also. So this becomes 4K and this becomes K. Let me solve it again. So it becomes K and K cancel. So 400 minus 4L1, it is equal to L1. So 400 is coming out to be equal to 5L1, or L1 is coming out to be equal to 80 centimeter. So from the left hand, L1 is coming out to be equal to 80 centimeter. Initially it was 20 centimeter. So the shift, it is equal to 80 minus 20, that is 60 centimeter. A little bit of calculation mistake while going through the problem. Such kind of mistakes do occur when you are attempting the paper. So please be very careful while dealing with such kind of problems, right? And I hope I made all the concepts clear. And with this, I'll end my session. And please keep tuned for more such session of physics in which we are going to discuss the problems of more chapters. Thank you very much for watching this.